Hello Legacy High. So today we're going to look at the beginning of our new unit, which is on polynomial functions, the roller coasters. So today we're going to look at some polynomial vocab, so when I'm saying certain words you're not blinking and staring at me with deer in the headlights. And then we got adding, and we're also going to look at subtracting polynomials, which is pretty easy. You're going to want your notes, and you're going to also want a calculator today just to do some simple adding and subtracting, okay? So let's jump into some terminology first. So there's certain kinds of polynomials, and you might have heard me call these things before. So if you have one term, now remember guys, term is one piece of a thing. Now monomial, that is one term. That's just basically a number, it's just a variable or a product of a number and a variable or one or more variables. So some monomials and possibilities, so some examples here. So we got 2. 2 is a monomial, it's just a number. You could have 2x, that's a variable with a number. You could have 2xy squared, that's also monomial. So basically a monomial is one thing, no adding and subtracting, just multiplication in there, okay? A binomial is two terms, kind of like a bicycle has two wheels. A binomial has two terms. So binomial would be an example like x plus 2. Notice there is a plus in there. It could be 3x squared minus 2x. Notice there's two things in here with a subtraction in the middle. So binomial is two terms, two monomials put together with an adding and subtracting. 3 terms is called a trinomial, kind of like a tricycle has 3, so it's tri. So this would be something that looks like x squared plus 3x plus 5, something like that. 3 pieces all attached with adding and subtracting. And then more than 3 terms, that is a polynomial. No, I'm sorry guys, we do not go above trinomial. So if you have more than 3 terms, 4 terms, 5 terms, heck, we could have 10 terms. That is known as a polynomial, okay? Just some more definitions to get in your head. What does it mean to be in standard form? You'll hear me, let's put it in standard form. Well, that means you're going to take it and rewrite it so you go from highest exponent to no exponent. Okay? So basically we're going to start with the squared, go to the go to just x, and then to the no x people. So we're going to want to write them in a linear format, if you want to consider it that way, or a descending order from exponents. Now you're going to say you're going to hear me say, what is the degree of this particular polynomial? The degree is what's known as the highest exponent present. So if there is an x squared term, that would be my degree of 2. We'll do a couple of examples of this. Now, there's this chart down here you're going to want to copy down. So you're going to want to do some pausing here. So I'll pause here for a moment. Did you write down the table? I bet you did. So I'll start talking here. So if I have a degree of 0, that is a constant. So that would just be like negative 14. Okay? 1 degree of 1, that's a linear function. That's 5x minus 7. Notice my degree is 1 because that's the highest exponent I have. Quadratic, you've heard of quadratic equation before. That is when there's a squared. Cubic is when there's a cube, or to the 3rd power. And a quartic is up to the 4th. Now, we don't have special names for the rest of them, but we do have degree of 5. That would have a 5th degree polynomial. That's what you would call that. Let's take a look and actually write a couple of things in standard form, and let's figure out its degree and whatnot. So standard form, so it looks like I have an x to the 4th, so he has to go first. So I'd have x to the 4th, and then we're going to go to this negative 4x squared, and then I have this 3 left behind, right? So now, this is in standard form. This really helps me find the degree, because the degree right here is this 4. It's the highest exponent. So my degree is a 4. So if I look back, or look on your notes, that little table, since it is a fourth, it has a fourth degree. So if I look back here quick, this is a fourth degree, so it is a quartic polynomial. Quartic. And then what kind is it? Is it a monomial, binomial, or trinomial? Well, there's three pieces, right? 1, 2, 3. So this is a quartic trinomial. Now, you're probably asking, what is this leading coefficient, Marsh? Leading coefficient is the number in front of the problem. Exactly. So there is nothing in front, though. Technically, there's a 1. So my leading coefficient is the number 1. So my standard form of this guy looks like I have 3x to the 4th first, shortly followed by a negative 3x cubed, followed by 7x squared, and bringing up the rear, I have a negative 4. This is a degree of 4, because that is my highest exponent, notice. So this is a quartic again, but since there's 4 terms, 1, 2, 3, 4, this is a polynomial. Okay. My leading coefficient, number in the front, big number in the front, right here, that is a 3. So my leading coefficient is 3. Now, let's look at just adding and subtracting monomials. So easy stuff, 1 terms only. So I got a couple of examples here we can look at. So I got 3x squared plus 5x squared. Now, you are not going to add the exponents, because only time you're going to add exponents is when this would have been multiplication. Notice, we're adding. So all we're going to do is add the numbers in the front. So this says I have 3x squareds, and I am going to add on 5 more x squareds. So that means I have 8x squareds in all. Notice this is not 8x to the 4th, it is 8x squared. You're not going to change your exponents because we're adding. Let's look at this one. We're subtracting, it looks like 4x cubed y minus x cubed y. So I'm going to subtract 4 minus 1 because you're just going to do it with the coefficients. So 4 minus 1, that is 3. And then I am just going to copy the rest of my my variables, excuse me. Let's try adding polynomials here. So I'm going to find the sum, and then I'm going to write the answer in standard form. So very first thing, I'm going to figure out who's like terms. So those guys are like terms, and these two guys are like terms. So 4w plus 9w, that is 13w. And then negative 5 plus 2, that is negative 3. So this would be my final answer, because I'm starting with an exponent of 1 and ending with a no exponent problem. Or an exponent of 0, if you want to think of it in that way. Alright, let's find some like terms here. So those guys, looks like these guys are like terms, and then these guys are like terms. So I got 2k squared plus 5k squared. Well, that is 7k squared. Negative k plus 3k, that is 2k's. And then 3 plus negative 7, that is negative 4. And yes, guys, this is that simple. It is pretty quick, pretty easy. Just need to make sure you find your like terms before you add. Subtracting, though, guys, is a tad bit different. You're going to want to be very careful with this. Very first thing I find a lot of kids mess up on is they forget to subtract things. So like what I like to do is give this negative into this second piece. So basically I rewrite so that I go like this. Minus 3n minus 8. So basically it's going to change all the signs on the inside of those parentheses, okay? Then it's basically like you were just doing. Find like terms. 5n minus 3n, 2n, negative 2 minus 8, negative 10. Done. Okay, same thing over here. Let's rewrite. So I got that. That guy's not going to change, but this is going to go to everybody in there. So normally this was a negative 2w cubed. This is going to be a positive 2w cubed now. a negative 4w squared, and a positive w. Because remember, we're changing everybody's sign because we're subtracting everybody. This guy, he looks like he's a singleton. This guy, looks like I got 2 people here, and then we just got 1 person here. He's all alone. So negative 6w to the 4th goes first, shortly bringing up the rear by 2w cubed. Let's combine our w squareds. Negative 3w squared, right? And then followed by a positive w. So my final answer, negative 6w to the 4th plus 2w to the 3rd minus 3w to the 2nd plus a single w. And that's the end of this video. See you later, Sabers.